Hi, and welcome to another physics video. In this one, we're going to deal with inelastic collisions in 2 dimensions. Let's start by reading the problem. A 1,325 kilogram car, C, moving north at 27.0 meters per second, collides with a 2,165 kilogram car, D, moving east at 11.0 meters per second. The two cars are stuck together. In what direction and with what speed do they move after the collision? Alright, let's get started. So let's start off with some information that we might know first. So immediately you'll notice that velocities for each car have a direction, but the velocity for car C is 27.0 meters per second north, and then the velocity for car D is 11.0 meters per second east. Now the scenario still follows a conservation momentum, but we're gonna have to make some modifications to our conservation momentum equation. So what we can start first is let's find the momentum of each car individually. Now looking at this, solving for the momentum separately, you have one momentum of car C going north and you have the momentum of car D going east. We can't just add them as they are not opposite of each other, or they're not the same direction of each other either. The directions of these two are actually perpendicular. So what does that look like exactly? Looking at the situation, if you look at the vectors that I drew there, that's representing the directions they're going, and then in that sense they're gonna collide in that manner. Now what happens after the collision? Well, if one's going north and one's going east and they clash and they stick together, well, they're gonna produce a combined direction that looks like this. And our cars combined will look like this after they crash. They will go in a diagonal direction. This might look familiar because if we combine the arrows in a different way, let's say, let me draw D first. And I'll draw C second, and then look, and this looks like a sort of right triangle. And of course, if we have a right triangle formation, we can find a hypotenuse by using Pythagorean theorem. So for this situation, we're gonna do this exact same thing. We're gonna use the momentum of let me use some colors here. We're gonna use momentum of part C and momentum of car D, and we are gonna put them place them in the Pythagorean theorem to find the final momentum. There we go. Now that we found the final momentum of the situation, we can also find the speed after the crash. And we know that after the crash, two objects are stuck together, and if they're stuck together, they both share the same final velocity. So since we have the final momentum and we know that the two cars are together when they crash, we take the final momentum and divide it by the total mass after the crash to get the final velocity. Now our answer isn't done yet because since we are solving for final velocity here, it is sort of missing a direction and angle. So we'll take a moment and solve for the angle by using a tan function, and then also using the initial momentum of car C and the initial momentum of car D. After finding the angle, our final answer for this inelastic collision problem, or two-dimensional inelastic collision problem, is going to be 12.31 meters per second at an angle of 56.34 degrees north of east. All right, so that concludes our video. Thanks for watching, and until next time.